Welcome to our deep dive into a reactive effect with computed properties. First, we define a function called reactive effect that receives a function fn. Inside, we have a store, a map that tracks the dependencies of our reactive system. Track is a helper function that registers the given key with the effect function. The trigger function is responsible for calling the reactive effects when a value changes. Finally, we execute the reactive effect and return the track and trigger functions for external use. Moving on, we create a reactive source object data with properties price and quantity. Then we set up an empty object computed store to hold our computed properties. We invoke reactive effect and track the total property. Whenever total changes, our effect function logs the new total to the console. Here we define a computed property total on the computed store object. With the get function, we track the price and quantity properties, returning their product. The set function allows us to set a new value for total and trigger changes, which reevaluates anything depending on total. To see the reactive system in action, we update the price in our data object. After changing the value, we call trigger with price as the argument, prompting the system to log the updated total automatically. Let's delve deeper into the reactive effect function. When effect is first called, it establishes initial dependencies by invoking fn. Dependencies are tracked whenever their respective properties are accessed. By returning the track and trigger functions, we allow external manipulation of our reactive system, making it versatile and powerful. Now, let's discuss how property access works with our computed store. When we access computed store total, it triggers the get function we defined. Track is called for price and quantity, thereby establishing them as dependencies. Behind the scenes, this is how our reactive system knows when to recompute total. Lastly, let's understand how track and trigger mesh together. These functions can be used to manually add and respond to additional dependencies, like discount here. When discount changes, we manually trigger an update, and all dependent effects are reevaluated, demonstrating the flexibility and power of our reactive system.